So now let's think about the Ricardian model. We just did an example of it, but let's think about developing it generally. So it's actually very simple. We're going to have a country that we're going to call home, okay? And for that country, we're going to think about something that we're going to call the unit labor requirements. So our unit labor requirements we'll use these in a couple of different models, but our unit labor requirements, we're going to designate this way. A, L, our good that home is going to, we're going to have two goods. We're going to be producing wine and cheese. So we're going to have a unit labor requirement for both wine and cheese for home. So let's call this one ALW. That's going to be our unit labor requirement for home to make wine. Okay, so this is our unit labor requirement for wine. The L here stands for labor, the W stands for wine. We're also going to have a unit labor requirement for cheese. Okay. These are just like the numbers I gave you in the first table with the farmer-rancher example. So if we were thinking about the farmer and we thought about the number of minutes that are required to produce meat and the number of minutes required to produce potatoes, all I was giving you were the unit labor requirements. Now I know that for a lot of students it feels much more comfortable to have 60 minutes or 1 hour in there instead of this thing. But I don't want you to be confused or get uncomfortable with this, because what I would do if I give you a problem is I'd just tell you that this is equal to 2, or it might be equal to 1/2. So this simply tells you the number of hours needed to make a unit of the good. Okay, so it's not, don't be confused or intimidated by it. We're also going to designate the amount of labor that we've got by L. This is going to be the total labor supply. Now, I also gave you that in the farmer-rancher example by telling you the number of hours that they were going to work. So in our second table, we had the amount that they could produce in an 8-hour workday. So there, the amount of labor that both the farmer and the rancher had was 8 hours. It's not the case that the two people or the two countries have to have the same amount of labor. One country could have more labor than the other. So what we'll see is we'll talk about what happens when they're different, and it's not hard at all. So again, don't be intimidated by any of this, but that's L is going to represent the total labor supply. We're going to think about the total production of wine and cheese. We're going to designate those as QW. This will be total production of wine, and QC is going to be production of cheese. So now let's think about how much wine and cheese our country here, home, can produce if that's all they produce. So the total amount of wine that they produce is going to be QW. If we think about the amount of labor used to produce that wine, it's going to be the unit labor requirement for wine multiplied by QW. So the amount of labor used, let's put it up here, amount of labor used to produce, say, wine is going to be the unit labor requirement multiplied by the number of units of wine produced. So this is for wine. So let's think about what that means. Let's suppose the unit labor requirement is 1. That means that home needs 1 hour or 1 unit of labor to produce a unit of wine. And if they produce 5 units of wine, then 1 times 5 would be 5. They need 5 units of labor to produce that much wine. The amount of labor used to produce cheese is going to be the unit labor requirement for cheese multiplied by the amount of cheese produced. So that's the amount of labor used to produce cheese. Okay, and again, this is just going to be one number multiplied by another number. Now, we can't use more labor than we've got. Home has a certain amount of labor given by L. They can't use more than that. Here's the amount of labor used to produce wine and the amount of labor used to produce cheese. So if we add these two up, we get the total amount of labor used. So if we take the amount of labor used to produce cheese plus the amount of labor used to produce wine, that has to be less than or equal to the amount of labor that home has. Okay, so this equation, this is actually the equation for the production possibilities frontier. Okay, so this is, let's write that. This is the equation for the PPF. And you can easily do this for the farmer-rancher example. As a matter of fact, I'll do it in a little bit later on. We'll just write out exactly what we're doing here for the farmer-rancher example, and you'll see that it's actually very simple. It looks more complicated here than it actually is. What we want to do is we want to graph this production possibilities frontier. Now, in order to graph it, what we need to do is we need to take this equation and we need to put it into slope-intercept form. But the way that we're going to do that is we need to decide which good we're going to put on the horizontal axis and which good we're going to put on the vertical axis. So let's draw this. I'm going to draw it right up here. Let's put the quantity of cheese on our horizontal axis. We'll put the quantity of wine on our vertical axis. Now, if we're going to put something into slope-intercept form, what we need to do is we need to solve for whatever we've got up here on our vertical axis. We need to solve for QW. So I need to do a little bit of algebra here to solve this thing for that. Okay? So what I'm going to do is I'm going to move this thing to the other side. So let's put here, it's going to leave me with the amount of labor used to produce wine has to be less than or equal to L minus this term. What I need is that by itself, so I'm going to divide both sides by the unit labor requirement for wine. So that's going to leave me with this, QW, less than or equal to L divided by the unit labor requirement for wine, minus the unit labor requirement for cheese divided by the unit labor requirement for wine multiplied by the quantity of cheese. So now, I've solved this equation for the production possibilities frontier for what I have on the vertical axis. Okay? And if it's been a while since you've done this, just think about this. What we've got here is QW and QC, but if you had, say, something you're probably more comfortable with, y and x, and you had some function, if you wanted to graph that function, what you would need is you would need y equals mx plus b. That's the slope-intercept of the intercept form of this line, and you need to have y by itself. Okay, then here's your slope, there's your vertical intercept, and so all we're doing is we've replaced our y and our x with q's. But I still need to solve for whatever variable I've got on the vertical axis there. So that's why I solved it for QW. But now we can easily graph this. If we graph it, here is our slope. It's the thing, the term that's multiplied by the other variable. And here's our intercept, our vertical intercept. Our vertical intercept is going to be L divided by the unit labor requirement for wine. Now that end point tells us the amount of wine that we can produce in home if that's all we produce. So let's do a quick example. Let's suppose that we've got, say, 8 hours for our total labor supply. Suppose L is equal to 8. And let's suppose that it takes 1 hour to produce a unit of wine. So ALW is 1. Then if we've got 8 hours, and it takes an hour to produce each unit of wine, if that's all we produce, we could make 8 units of wine. It would be 8 divided by 1. Or if we had 8 units of labor and it took 2 hours to make each unit of wine, then we'd be able to make 4. 8 divided by 2 would be 4. Okay? So we did this same thing with the farmer-rancher example, except we just had a number there. Here, this is what that number looks like, though, if you actually do it algebraically. We're going to have a line. This is linear. And the slope of that line is right there. It's going to be equal to, our slope is going to be equal to the ratio of the unit labor requirements. It's the unit labor requirement for cheese divided by the unit labor requirement for wine. You can verify in the farmer-rancher example, we'll do it a little bit later, that all you have to do is take the ratio of those numbers that I gave you in the first table, and you'll get the slope of that production possibilities frontier. This end point down here is going to be the amount of labor we've got divided by however much time it takes to produce each unit of cheese. So it's the unit labor requirement for cheese. So right there is a general version of what the production possibilities frontier looks like. It's not hard to derive. We're just using this statement that tells us that we can't use any more labor than we've actually got. Okay? But this is exactly what we did with our farmer-rancher example. Our opportunity cost then, the opportunity cost of the good on the horizontal axis is given by this term. It's going to be equal to the unit labor requirement of the good on the horizontal axis, that's in our numerator, divided by the unit labor requirement for the other good. There's our opportunity cost. So you can start with the unit labor requirements for home, and you can immediately, our unit labor requirements are right here, you can immediately figure out the opportunity cost. You don't necessarily have to graph the production possibilities frontier, although I would if I were working on a problem. So this production possibility frontier tells us that they're capable of producing any good on the PPF or inside the PPF. That's what this inequality tells us. You can produce anything less than or equal to a quantity that lies on that line. What we need to do now is we need to think about what I'm going to call an ISO value line. And that's probably something that you've never seen before. At least you may not have seen it referred to as an ISO value line. You probably in a class or two have talked about that, so it won't be something completely new, but the terminology is going to be new. So I need to erase this, and then we'll think about what an ISO value line looks like. So let's think about what an ISO value line is. If you think about the word ISO value, ISO means same, and then value, same value. So what this is going to be a line that represents combinations of output with the same value. Now, the production possibilities frontier is also an ISO value line. We don't call it that early on because it would just be too confusing. But remember that a production possibilities frontier represents all of the possible combinations of output that you can produce using the same amount of labor. So what I just had up here was an ISO value line that represented all combinations of wine and cheese that used L units of labor. So it's the exact same idea. If you've seen let's say you've had your intermediate micro class and you talked about a budget constraint. A budget constraint, remember, represents all the combinations of the two goods that you can buy that costs whatever income you've got. So that's also an ISO value line. So you've seen it before, you just may not have heard this term. So let's talk about the value of production. So what we have so far is we've talked about a production possibilities frontier. And that shows all the possible combinations of the two goods that a country or a person can produce. But then the next question is, which bundle do you actually produce? Now in the farmer-rancher example, the way we solved that was that we just said, okay, let's suppose the rancher proposes a particular bundle to the farmer, and then the farmer agrees to it. In the real world, that's not typically how it's going to work. In the real world, we know that things are determined in markets. And so the bundle that you actually choose to produce is going to be dependent upon how much you can sell each good for in the market. And so you want to, when you're making that decision, you want to choose the bundle that maximizes the value of what you're selling. Okay, so you're going to maximize the value of what you're producing. So let's write this out. The value, we're going to designate that as V. The value of what you produce is going to be equal to the number of units of, say, wine that you produce times the price of wine plus the number of units of cheese times the price of cheese. So here's the amount of money you make off of the wine you produce, and here's the amount of money you make off of the cheese you produce. And if you add those together, that tells you the value of what you've produced. And your goal is to maximize that amount that you get from selling the wine and the cheese. Now what we want to do is we want to graph this. And so we're going to be graphing it in this space. I'm going to, let's put it right over here. I'm going to graph it with QW on our vertical axis. That's just like the picture that we drew with our production possibilities frontier. We're going to have QW on our vertical axis, quantity of cheese on our horizontal axis. We want to draw it in that space, okay? So we're going to do the same thing that we did for that PPF. If I want to draw this, it's not in slope-intercept form. I need to put it in slope-intercept form so that I can draw it on here, which means I need to solve for that. I need to solve for the quantity of wine, that term right there. So let's do that. I'm going to do a little bit of arranging. I'm essentially going to move this term over here. I'm going to subtract it, but I'm going to reverse the terms. So what I'm going to get is QW divided by the price, or excuse me, multiplied by the price, is going to be equal to V minus the quantity of cheese times the price of cheese. So all I've done is subtract this term from both sides. Okay? Now I want this by itself, so I'm going to divide by the price of wine. That leaves me with QW on the left side. I get V divided by the price of wine minus QC, minus, let's put our price there, minus PC over PW times QC. So now I've got quantity of wine by itself, and I've got my intercept, and I've got my slope. And you should see that that, in a lot of ways, is very, very similar to the production possibilities frontier that we just graphed. It's also very similar to what the equation of a budget constraint would look like. In that case, you would also have prices, but that V would be income. But other than that, it looks very similar, hopefully, to something you've already seen. So let's graph this. Our vertical intercept is V divided by the price of wine. It's downward sloping. The slope here is the relative price. It's P, the price of cheese, divided by the price of wine. We call that the relative price of cheese. And then we don't have it here, but if you were to solve for our horizontal intercept, it would be V divided by the price of cheese. It would look like that. So there's an ISO value line that represents all combinations of wine and cheese that are of the same value. Okay, this bundle has the same value as that bundle, the same value as any bundle on here. Now, a bundle that's back here would have a smaller value, and a bundle out here would have a higher value. But all of the bundles on that line have the same value, so it's an ISO value line. Now, what we're going to be doing is we're going to be using this idea of an ISO value line to figure out which of the possible bundles that the country can produce is the one bundle that they're going to choose. So let's remind ourselves here that an ISO value line farther from the origin has a higher value. That's important. Okay? So any ISO value line out here, for example, if I were to draw an ISO value line right out there, all of the bundles on that ISO value line would have a higher value than these bundles would on this ISO value line. And you can see that easily. If we were to increase V, then both of these intercepts would move out, and the ISO value line would shift out into the northeast direction. If we were to decrease V, then both intercepts would move towards the origin, and our ISO value line would move back in this direction. Okay? So the country or the person wants to get to the ISO value line that's farthest from the origin. That's going to be the goal. So let's do a quick example. Let's suppose that I occasionally will use symbols in this class. Some of you will have seen them before. That symbol of an S with a little line through the bottom is the symbol that I'm going to use for the word suppose. And I'm going to use that frequently. So let's suppose that V is equal to 20. Let's suppose the price of cheese is equal to 4 and the price of wine is equal to 2. Okay? So we're just going to pick some prices and we're going to think about a value, and then let's put that into this function. So our value is equal to 20. That's equal to, let's do price of wine first. It's going to be equal to 2 times QW plus 4 times QC. So all I've done is plug these numbers into there. Now I want to graph this, so what I need to do is I need to solve for QW. So let's go ahead and do that. 2 QW is equal to 20 minus 4 QC. Then I'm going to divide by 2. So QW is equal to 10 minus 2 QC. So there's an ISO value line that represents all of the bundles of wine and cheese that have a value of $20. And if I were to draw this, then it would be very easy to draw. Let's put our quantity of wine again on our vertical axis, quantity of cheese on the horizontal axis. I'm going to be careful about my units here. 1, 2, 3, 4, 5, 6, 7. So there's 10, which is my intercept, my vertical intercept. So right up there's where this ISO value line starts. It has a slope of -2. So I go down 2 over 1, down 2 over 1. By the time I've gone down 10, I will have gone over 5. So there's the other end of that ISO value line. It's linear, and it has a slope of 2 or -2, right? Which is the ratio of our two prices. It's the price of cheese divided by the price of wine. 4 divided by 2 is 2. So there's an ISO value line. If I were to increase V from, say, 20 to 30 and then draw that ISO value line, it would be somewhere to the northeast of this one. Or if I were to decrease the value to, say, 10 and draw that ISO value line, it would shift down in this direction to the southwest of that one. So that line represents all of the possible bundles of wine and cheese that have a value of 10. Let's think about how each of these, or excuse me, have a value of 20. Let's think about how each of these endpoints works. So this endpoint, right, where the country is producing 10 units of wine and no cheese. So 10 units of wine times the price of wine, which is 2, is equal to $20. So the value of what they produce is 20. If we look at this endpoint, they're only producing 5 units of cheese, but cheese has a price of $4, which is equal to 20. So both of these endpoints have a value of $20. You could choose any other point on here, and if you take that quantity, multiply it by the appropriate price, add to it the other quantity multiplied by the appropriate price, you'd see that any bundle on that line also has a value of $20. It's a line of equal value, okay? Now, what we want to do is we want to take this concept of an ISO value line and we want to figure out how that helps us determine which production point the country is going to choose. So in order to do that, I need to clear the board here and start with another picture. So let me do that. So now what we want to do is we want to use the output prices and the idea of this ISO value line to figure out the bundle that our country is going to choose. So let's think about a production possibilities frontier. So let's suppose we have a production possibilities frontier that looks like this. Let's have our quantity of cheese down here, quantity of wine up here. I'm going to be a little bit careful about my units here. So 3, 4, 5, 6, 7. Let's have units up to 10. Same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to use that 9 and 1, 2, 3, 4, 5, 6, 6. Let's suppose we had a production possibilities frontier that looked like that. Okay, so this is a production possibilities frontier. So what this tells us is that this country or this person can produce any bundle on or inside of this frontier. They could produce 9 units of cheese and no wine, or they could produce 6 units of wine and no cheese, or they could produce any bundle on that production possibilities frontier. But what we want to do is figure out, well, what's the bundle they are going to produce? Now, the bundle that they're going to choose to produce is going to be dependent upon the price of cheese and the price of wine. And we're going to use this idea of an ISO value line to help us figure that out. So let's suppose that the price of cheese is equal to 4, and let's suppose the price of wine is equal to 2. Okay? So what we want to do is we want to consider a couple of different points. Let's just pick a point on this production possibilities frontier. Let's suppose that we start with this point where they can produce 4 units of wine and 2 units of cheese. That would be a point on that production possibilities frontier. Okay, let's call that point A. Now, what we want to do is we want to look at the ISO value line through that point. Now, our ISO value line we just saw is going to have a slope equal to the price of cheese divided by the price of wine. So the slope of the ISO value line is going to be the price of cheese divided by the price of wine. It's going to be equal to 4 over 2, which is 2. The slope of our ISO value line is 2. Now the slope of this production possibilities frontier is going to be 6 over 9, right? It's going to be 2/3. So our ISO value line that represents the relative price of cheese is going to have a steeper slope than that production possibilities frontier. Let's suppose that we draw the slope of the ISO value line through point A. It's going to have a slope of -2, so it's going to be something similar to that. That slope of this little line segment right here represents the slope of the ISO value line. Now, let's consider a different point. Let's suppose we think about a point down here where they produce 2 units of wine, and it's going to be, what, 6 units? 6 units of cheese. That would be another point on that production possibilities frontier. Let's call that point B. If we were to draw the ISO value line through point B, it would also have a slope of 2 or -2. It would look something like this. So these two segments right here are going to be parallel to each other, both with a slope of -2. And what we see is that this ISO value line is farther away from the origin than this ISO value line, meaning that if this country has a choice between A and B, and it wants to maximize the value of what it's selling, they would rather produce and sell this bundle than they would that bundle. Bundle B has a higher value than bundle A. Okay? We could calculate the value of these two bundles, and you can verify that producing 4 units of wine and 2 units of cheese at those prices has a lower value than this bundle B. So they would rather be at bundle B than bundle A, but it turns out there's an even better bundle, isn't there? You can see that there would be a bundle right down here with the same slope. It's not quite parallel, but pretend that it is. That bundle right down there where they produce only cheese has a higher value than either of these two bundles, A or B. So what we see is that the two prices here are output prices that are going to be determined in the world market. We'll talk about that here in a little bit. Those two prices are going to be the way that each country decides what they're going to produce. Now, this shouldn't be surprising to you because you already know from the farmer-rancher example that you're going to tend to specialize. You're going to tend to produce one good or the other. In our farmer-rancher example, the rancher didn't. We'll talk a little bit about that later. Actually, in that example, the gains from trade would have been even bigger had the rancher specialized completely in meat. So, what we've got here is now a way of figuring out which bundle each country is going to produce as long as we know the output prices that they face. What we need to do is figure out how these prices get determined, but that will be easy. As with most things in economics, it's going to boil down to demand and supply. So it'll be something you've seen before. So we'll erase this now and get back to our example of our production possibilities frontier. So let's think about now how much each input, or how much the input, labor, is going to be paid in this model that we're developing. So our only input in this particular model is going to be labor. We'll have other models where we have a couple of inputs later, but for now all we've got is labor. And labor is going to move to whichever sector, either the wine sector or the cheese sector, in which it's paid the most. So we've got here PC, which we're letting designate the price of cheese. And then we've got PW, which we're going to designate as the price of wine. Now, one of the basic things that we know about microeconomics is that the hourly wage for an input is going to be equal to the value of what that input can produce in an hour. So we need to think about in this model what that looks like. So we've got our unit labor requirements. Remember that our unit labor requirement for cheese, this represents the number of hours needed to produce a pound of cheese or a unit of cheese. So this is number of hours to produce 1 unit of cheese. So if we take the inverse of that, that's going to be the number of pounds that can be produced in an hour, or the number of units that can be produced in an hour. 1 over that unit labor requirement, that's the number of units produced in an hour. And let's think about why that makes sense. Okay, let's suppose that the unit labor requirement for cheese is 2. So that means that it takes 2 hours to produce a unit of cheese. Well, if we want to know how much cheese can be produced in 1 hour, then if we take the reciprocal of that, the reciprocal of 2 would be 1/2. That means in each hour, they can produce a half unit of cheese. Okay, so it's a little confusing when you think about the unit labor requirement and its reciprocal, but if you just pick an example, here's the simplest example. If this was 1, it takes 1 hour to produce a unit of cheese, then each hour they could produce 1 unit of cheese, okay? Because the reciprocal of 1 is 1. So now, if we wanted to know the value of what this input can produce in 1 hour, here's the amount that they can produce in 1 hour. Here's the price of it. So if we take the price and multiply it by the amount they produce, P times 1 over the unit labor requirement, this product is going to be the value of what a worker can produce in 1 hour. This is the value of what a worker can produce in 1 hour. Now this is important because we're going to use this a lot. I'm going to write it this way. I'm just going to write P over the unit labor requirement. Okay? So that's going to be the value of what a worker can produce in 1 hour if they're producing cheese. This is going to be, let's make this PC because we need to multiply it by the price of cheese. If we wanted to know the value in terms of wine of what a worker could produce in an hour, this would be the hourly wage in the cheese sector. Hourly wage in cheese sector. And if we wanted the hourly wage in the wine sector, it would be the price of wine divided by the unit labor requirement for wine. That would be the hourly wage in the wine sector. So now, let's consider a situation where wages in the cheese sector are higher than wages in the wine sector. So we just want to think about what would happen in that case. So let's suppose wages in the cheese sector are higher than the wine sector. Let's think about what that would imply. Let's write out that statement. So wages in the cheese sector, here's the hourly wage in the cheese sector, are greater than wages in the wine sector. Now let's do a little bit of rearranging there. I'm going to divide both sides. I'm going to move this PW down here, and I'm going to move that unit labor requirement for cheese right up there. So since this is an inequality, I can do that without changing the inequality or anything like that. So I can rewrite this equivalently. So there's an equivalent statement to this one. Okay? So if wages in the cheese sector are higher than wages in the wine sector, then that tells us that the relative price of cheese is higher than this slope right here. Now remember that this is the slope of the production possibilities frontier, and this is the slope of that ISO value line that we just talked about. Okay? So this tells us that if wages in the cheese sector are higher than the wine sector, then workers are going to move to the cheese sector and we would specialize in cheese. Specialize in cheese. Now that's exactly what we saw when we were talking about that example with the ISO value line. If the slope of that ISO value line is steeper than the slope of the production possibilities frontier, then the bundle that produces the highest value is going to be down there in that bottom right-hand corner where they produce all cheese. So this isn't anything new. All we're doing is we're using what we know about labor and the fact that labor will move to whichever sector it is paid the most in to understand why the economy would specialize in cheese if the relative value of cheese is higher than the opportunity cost of producing cheese. Okay, so this is a key result, and it's something we're going to use a lot. What it tells us is that if the relative price of cheese is higher than the opportunity cost of cheese, that economy will specialize in cheese. The other side of that coin is if the relative price of wine is higher than the opportunity cost of producing wine, then the economy will specialize in wine. And we didn't draw that picture. That would be a picture where the ISO value line has a smaller slope than the opportunity cost of producing cheese. So we could go through that, and we will in a later example, but you're going to specialize in cheese if the relative price of cheese is higher than the opportunity cost of producing it. Here's another thing that we need to kind of finish this section with, and that is, in the absence of trade, the relative price of cheese is going to be equal to the opportunity cost of cheese because there's no other place to purchase cheese from. In the absence of trade, in the autarky situation, there's no other place to buy cheese or wine. And so the relative price that you're going to pay for them is going to be equal to your opportunity cost of producing them. What we need to do now is go back to that general trade model, and we've set this model up for a single country, for home. Now let's add another country, which we'll call foreign, and then we'll kind of work through what the trade model looks like. We'll see where these prices are determined, and then once we see that, we'll have kind of the whole model to work with.